The third method for determining transport numbers is the moving boundary method. Let's consider it in the following example. Solutions of two salts of potassium chloride and barium chloride having a common anion are placed in a narrow vertical tube so that they form a sharp interface. A silver electrode is soldered to the bottom of the tube. The concentration of salt solutions is selected so that, as a first approximation with an accuracy of 6 to 10%, the concentration of salt solution is selected so that, as a first approximation, the regulating ratio of Colruyt is fulfilled. Moreover, the transfer number of the lower solution should be less than the upper. If these conditions are met, then, when an electric current which causes the cations to move upward is passed through the system, the boundary of the two solutions is not washed out and moves up. After a certain period of time, the body takes a new position. If during this time Q coulombs of electricity passed through the system, then the amount of electricity transferred by potassium cations will be equal to the corresponding charge should be equal to the charge of all potassium cations that were contained in the volume between the AB and A bar B bar levels. Therefore, and for this example, when using this equation, the reference system is not the solvent as a whole, but the glass tube of the measuring device. The difference in this reference system is due to some movement of water relative to the glass tube, which associated with a change in the volume recorded in the moving boundary method due to electrode reactions. So, in the considered example, when passing an electric current, not only the cations move but also the anions and the electrode process of converting metallic silver to silver chloride. The result is an additional change in volume equal to Therefore, the volume recorded by the movement of the boundary from the AB to the A bar B bar position also contains the delta V value. Thus, in order to obtain the transport number relative to the solvent as a whole, it is necessary to make the correction. With the expansion of concentrated solutions, the correction for the movement of the solvent relative to the tube is very small. However, it is of fundamental importance, since it shows that the transfer numbers depend on the chosen reference frame. The accuracy of measuring transport numbers in the moving boundary method is determined by the accuracy of the reference position of this boundary.